All right, so for number 1, we're going to be doing long division. If you look at the 4 choices, you can see just by looking at my first choice and my second choice that those answer choices are kind of set up to look like the way we would write a long division answer, so that's what I'm going to go with. Just be careful when you're doing the long division, though. Look at what I'm dividing. Notice I have to make my powers go in descending order, so I want them in standard form. So we don't have an x squared term, so remember, we want to represent an x squared term by writing 0x squared. All right, so let's go through this. So I'm going to start by asking myself, what do I multiply this x by right here to get to 5x to the 4th? So that would be 5x cubed. Now from there, I want to take this 5x cubed and I want to multiply it by the x, which would give me 5x to the 4th. And then I want to take this 5x cubed and I want to multiply it by that 7. And that's going to give me plus 35x cubed. All right, now, at this point, don't forget that we need to change our signs here. So my 5x to the 4th is currently a positive, so remember I'm going to change that to a negative and circle. And I'm going to change this 35x cubed to a negative and circle. All right, well, our 5x to the 4ths are going to cancel out. And then I'm just going to do 33x cubed and a negative 35x cubed, and that's going to be negative 2x cubed. And then I bring the next term down, and I'm going to start again. All right, so this time I'm going to ask myself, what do I multiply this x by to get to negative 2x cubed? All right, so that's going to be minus 2x squared. Then I'm going to take that minus 2x squared and I'm going to distribute it or multiply it by both of these terms. Okay, so when I do that, I'm going to get negative 2x cubed and I'm going to get minus 14x squared. So now remember, we're going to be changing the signs and circle, change and circle. And my negative 2x cubes are going to cancel out. Then I'm going to add, and I'm going to get 14x squared. And let's bring down the 96x. All right, and we start again. So I'm going to take this x again and ask myself, what do I multiply this x by to get to 14x squared? So that's going to give me positive 14x. Now I'm going to distribute that through, so that's going to give me 14x squared. And then that's going to give me a positive 98x. All right, so now remember, we're going to circle, change. So change and circle rather, sorry. Change and circle, change and circle. And then I know that my 14x squareds are going to cancel out. And then I'm going to get negative 2x. And let's bring down that negative 16. All right, one more. So now I'm going to ask myself, what do I multiply this x by to get to negative 2x? And that would be a negative 2. So negative 2x here, and distribute it through to the 7 as well, which would give me minus 14. And then, remember, that we are going to change and circle, change and circle. And my negative 2x and my positive 2x will cancel out. And then we're going to do the last step here, and we will be left with a negative 2. So then that will give us minus 2, because that's our remainder, over the x plus 7. And if you look at that, you will see that that is answer choice 1. So number 2 is exactly like number 1. The directions are a little bit different, and it's not multiple choice, but otherwise pretty similar. Let's just look at this for a second. So they give you a of x and they give you b of x. But if you read the directions, let's just look at the first part. It says to express a over x divided by b over x. So look at what I did below. I took a of x and I'm dividing it by b of x. Now this is how they're telling you to express our answer. I'm going to hold off on that for a second. So I know that I'm going to be doing division here, okay? And it's a show your work question, it's not multiple choice, so I'm just going to do long division. All right, so we're going to start like we did the last one. So what am I multiplying the x by to get to 2x to the 4th? So that would be 2x cubed. Then I'm going to distribute that through, and that's going to give me 2x to the 4th plus 2x cubed. All right, so just like the last one, we need to change and circle, change and circle. And the 2x to the 4th are going to cancel out. And then we're going to combine our like terms over here, and that will give us negative 10x cubed. Now, I didn't say this, so let me say this right now. Notice again, I put a 0x squared here because we were missing an x squared term. So don't forget to do that when you're doing this kind of a question. All right, so I'm going to bring that down. So plus 0x squared. Let's bring that down. All right, so let's try again. So what do I multiply x by to get to negative 10x cubed? And that would be negative 10x squared. Let's distribute that through. So that's negative 10x cubed, and that'll be minus 10x squared. We are going to change and circle, change, oops, that's a plus sign, and circle. And our negative 10x cubed and positive 10x cubed are going to cancel. And then on this right side here, we will get 10x squared. Drop down the next term. And let's do it again. So what am I multiplying this x by to get to 10x squared? And that would be a positive 10x. So I'm going to multiply that through, and I'm going to get 10x squared plus 10x. And then we're going to change and circle, cross out your first terms. We're going to add your like terms over here, and we'll get negative 5x. And let's bring down my last term there, which would be a minus 4. All right, so what can I multiply this x by that will give me negative 5x? So that would be minus 5, right? So minus 5, let's distribute that through, and that is going to be a negative 5x and a negative 5. Then we're going to change and circle, change, oops, and circle. Cross out your first terms. All right, and then we're going to combine like terms there at the end, and that is going to be just a 1. So there's our remainder. All right, now let's just take a second and let's look at the directions over here. It says to express the division, which we just did, we just divided, but they want it in this form. So remember, Q of x stands for the quotient, and quotient is this expression right here. That's our answer. That's an answer to a division problem. And then plus the remainder over what we divided by. So, as our final answer then, we're going to write that it's 2x cubed, oops, let's make that look like an x, 2x cubed minus 10x squared. Oh my goodness, I don't know what's happening with my x's. I'm sorry about that. Plus 10x minus 5, and here we go. That 1 is a positive 1, right? So we're going to write plus the remainder over what we divided by, which is x plus 1. So this is our answer in the form of q of x plus the remainder over what we divided by. Okay? For number 3, probably the easiest thing to do after we read the question is the remainder theorem. So let's read what it says. It says, determine the remainder. That's all it wants, is the remainder when we divide this polynomial by x plus 2. Now we could do long division, which is a lengthy process, and you guys are good at long division, but doing the remainder theorem I think works a little bit better, and it's quicker and less painless, to be honest with you. Now, we're dividing by x plus 2. So remember, x plus 2 is a factor. So if I want to take this and use the remainder theorem, I have to find its 0. So remember, if x plus 2 is the factor, then x equals negative 2 is the 0. So basically then what I'm going to do is I'm going to take this 6x cubed minus 4x squared minus 5x plus 9, and I'm going to, according to the remainder theorem, I'm going to plug in a negative 2. And when I plug in negative 2 for x, that's going to give me my remainder. So I'm going to do 6 times negative 2, that quantity cubed, minus 4 times negative 2, that quantity squared, minus 5 times negative 2, plus 9. And you can type this into your calculator. And when you get that, you're going to get negative 45. The other way you can do it is by plugging it into your calculator. So if you look here, what you can do is you can store in negative 2 as x. So negative 2 store as x. Make sure that you hit enter and see this on the right-hand side of your screen. Then type in the polynomial, and there's your remainder right there. I think, honestly, that's probably even a better way to do it. Now, again, you can do long division, and you will get the same thing. So let's do that way. So if I have x plus 2, and I'm dividing that into 6x cubed minus 4x squared, make sure I don't have any terms that I'm missing, which I'm not, minus 5x plus 9. So I'm going in standard form there. So I'm going to multiply this x on the outside times 6x squared, and that's going to give me 6x cubed, distributing through, plus 12x squared. Then, like usual, I'm going to change and circle, change and circle. All right, so, oops, I'm going to cancel out those x cubed terms, and then I'm going to add, and I will get negative 16x squared. Let's bring down that negative 5x, and let's start again. So what am I going to multiply this x by to get to negative 16x squared? So that would be minus 16x. Distribute through, that'll give me negative 16x squared, and minus 32x. Oh my gosh, I'm sorry, I don't know what's going on with those x's. Okay, so then we're going to do our change and circle thing, right? So change and circle, that's a plus sign. And my x squared terms are going to cancel out. And then I'm going to add here, and I will get 27x and bring down the plus 9. All right, last time. So I'm going to multiply by a 27. because that will give me 27x. And then 27 times 2 will give me a positive 54. Alrighty then, so same thing again. So we're going to change and circle, cross out our x terms. And then I'm going to add my like terms over here, and there we go. That's negative 45, and there's your remainder. That's a really long way to do it. I wouldn't suggest it, but the remainder theorem is probably your best way to go. If we want to determine all the factors, now we've done a few of these questions in class. Basically, you're going to divide, get an answer, and then we will probably factor that answer again. Let's look and see what happens. So I'm going to figure out what I multiply 2x by to get to 6x cubed. And that is going to be a 3x squared. So when I distribute that through, that's going to give me 6x cubed, and then minus 3x squared. All right. So let's change and circle, cross out our x cubed terms. And then we're going to add our like terms, and that's going to give me negative 26x squared, and bring down the minus 47x. All right, so let's do this again. So this time I'm going to multiply by a negative 13x, because that negative 13x, when I distribute it through, is going to give me negative 26x squared and positive 13x. Okay? All right. So we are going to change and circle, cross out our x squared terms, and combine like terms over here, and that's going to be negative 60x. And let's bring down that positive 30. All right, last time. So that 2x is going to have to get multiplied by a negative 30, and let's distribute that through. So that's going to be negative 60x, and that's going to be a positive 30. Well, that works out very nicely for us, because remember, we have to change and circle, and everything cancels out, so we have no remainder. Perfect. So we know then that 2x minus 1 is a factor, even though it did tell us that, but we know that it's a factor because we have no remainder. Now, so what we have here then is we have 2x minus 1 is one of the factors, that's what they gave us, and then what we just found out is 3x squared, or quotient, minus 13x minus 30 is also a factor. However, that second factor here, this one right here, can be factored further. So we want to factor this further. So we're going to do rainbow, because our lead coefficient is a 3. So we're going to figure out what multiplies to negative 90 and adds to 13. Okay. All right. So I'm just going to keep bringing this 2x minus 1 down because it's a factor and I don't want to forget it. So, all right. So remember, when we do rainbow, we bring the first term down and we bring the last term down. Okay. And now let's figure out what multiplies to negative 90 and adds to negative 13. So you can go to your calculator if you don't know. Go to your y equals and plug in negative 90 divided by x. All right, so you should end up with a negative 18x and a positive 5x. Okay, we're going to group and we're going to group. Again, let's keep bringing down that 2x minus 1 factor so we don't forget it. All right, so this first group here, 3x squared minus 18x. Well, there's a GCF of 3x, so let me take that out, and I'm left with x minus 6. And my second group of 5x minus 30, I see that they both have a factor of 5, and then I have x minus 6. And that works out nicely because remember, this parentheses here and this one here should match up. All right, so again, let's keep bringing down that 2x minus 1. All right, so we take our GCFs, which is the 3x and the 5, and put that in one parentheses. And then we drop down the x minus 6. So let's read the question. Determine all the factors of the expression. So if you look at what we have here, this is factored completely, and those are all the factors. So we have 3 factors. 1, 2, 3. So for this question, they're giving you a polynomial, h of x, and notice we have a term here that we don't know. But they are telling me that h of negative 8 equals 0. Well, that's the remainder theorem. So that's telling me that when I plug in x equals negative 8, I have a remainder of 0. So in other words, I have a factor, and here we go. Okay, so if h of negative 8 equals 0, then that means the factor x plus 8, or I should say, x plus 8 is a factor. Okay, so let me just kind of say that again. So if here the value of x equals negative 8 goes in evenly, in other words, has a remainder of 0, then I know x plus 8 has to be a factor of this polynomial h of x. Okay, so I know by the remainder theorem that I can just plug in this negative 8 here into all my x values here, and I should get 0 over here. So I think that's probably the easiest way to go about this. So let's start with that. So I'm going to write 0 equals 6 times negative 8, let's cube that, plus b times negative 8 squared minus 23 times negative 8. Oops, let's make that a little bit darker. And then minus 120. Now if you look at this, what this is going to help us do is it's going to help us find that b value, because I can't do anything else in this question until I find that b value. All right, so let me keep going. So I'm going to have 0 equals, so when I multiply all of this out in my calculator, I'm going to get negative 3,072. Okay, then I'm going to get plus 64b plus 184 minus 120. And keep going. So that's going to give me 0 equals negative 3008 plus 64b. Now I'm going to move this negative 3008 over to the left-hand side, which is going to give me positive 3008 equals 64b. Then I'm going to divide out the 64, and I know that b is 47. Okay, now that hasn't really helped me to directly find the answer, but we're on our way, because now I know that h of x is equal to, oops, hold on one second here. Oh, here we go, is equal to 6x cubed. Now I know what b is, so I'm going to replace b with 47x squared minus 23x minus 120. Okay, so now I know what h of x is equal to. Let's go back and reread the directions. So it says, given that h of x is equal to all of that, now remember, we know what b is now, okay? And we know a 0, right? So when x is negative 8, y is 0. which, remember, what that tells us is x plus 8 is a factor. And it says algebraically, now that's big, because it says algebraically determine all the zeros of h of x. Now, if it didn't say algebraically, couldn't I plug this into my y1 and just look and see where this function hits the x-axis? But because it says algebraically, I've got to show work. So what you want to do next is let's take h of x, and we know that x plus 8 is a factor, so I'm going to take this x plus 8 and divide it into my h of x. And let's do that. All right, I'm going to try to squeeze it in down here. Hopefully I can. Okay, so I've got x plus 8, and I'm going to divide that into 6x cubed plus 47x squared minus 23x minus 120. And notice that my h of x is in standard form, and I'm not missing any terms, so I don't need any zeros to hold the place. All right, so here we go again. So I'm going to take x, and I'm going to ask, what do I multiply it by to get to 6x cubed? So that's going to be 6x squared, which is going to give me 6x cubed. And then let's distribute that in, and that's going to be plus 48x squared. Okay, so let's change and circle, and my first terms cancel out. All right, so let's combine like terms, and I end up with a negative x squared. And I'm going to bring down that 23x. All right, so next, I'm going to ask myself, what do I multiply x by to get negative x squared? And that's going to be minus x. So let's distribute that minus x through. So that's going to give me negative x squared minus 8x. All right, and let's do this again. So we're going to change and circle, and our first terms cancel out. Okay, so we're going to add negative 23x and a positive 8x, and that will be negative 15x. And let's bring down that last term. Last time, so what do we multiply x by to get to negative 15x? That would be a minus 15 or a negative 15. So we're going to distribute that negative 15 through, and that's going to give me negative 15x. And negative 15 times a positive 8 is going to give me a negative 120, which this works out very nicely because I'm going to change and circle, and both terms cancel out. So I have no remainder left, which is what I want because I know that x plus 8 is a factor. All right, so now let's look at what we have here. So we know that we have x plus 8 as a factor, and now we know we have 6x squared minus x minus 15 as the other factor. All right, so let's look at that a little bit further then. So we can rewrite this, as you see right here, both of those being factors. Now we've done this before as well. So we know x plus 8 is a factor, and so is the 6x squared minus x minus 15. But I do know that this 6x squared minus x minus 15 can be factored further. So I'm going to do just that. So I'm going to factor further, and I'm going to do the rainbow method. Because my lead coefficient, remember your lead coefficient is the number in front of the highest power, in this case the x squared, is not a 1. All right, so what I'm going to do is I am going to make my rainbow going from my first term to my last term, and let's multiply those. So I want to figure out what multiplies to negative 90 that would add to a negative 1. And again, you can put that in your calculator. Go to y equals and do negative 90 divided by x. Okay? And then you go to your table and you look for values that obviously they should all multiply to 90, but that would add to a negative 1. All right, so first step here, though, when we're doing rainbow, remember we always bring down the first term. So I'm going to bring down the 6x squared, and we bring down the last term, which is the minus 15. Okay, so I went to my calculator and I looked for two numbers that multiply to negative 90 and add to negative 1. And I got negative 10x and plus 9x. Now, just a quick note. Whatever your middle term is here, in this case it's an x, that's the variable that will go next to these two numbers right here. Okay? All right. So then next what we want to do is, remember, we want to group. So we're going to group our first two terms, and we're going to group our second two terms, and we're going to look for a GCF that we can take out of each of those. So if I look at my first grouping, 6x squared and minus 10x, I can take out a 2x, and when I divide that in, I get 3x minus 5. Okay, my second grouping, I can take out a 3, and I'm left with 3x minus 5. So finally, if I factor that, I will get 2x plus 3. Those are the two GCFs, right? And then the 3x minus 5. Okay. However, do not forget that this is a factor, so we're going to just scoot that right in front. So these three terms, 1, 2, 3, are the factors that if we were to multiply these three together, we would end up with h of x. Now go back and read the question. It says algebraically determine all the zeros of h of x. Well, this essentially, actually, how about we just write this? This essentially is h of x, just in factored form. Now what they want us to do is determine the zeros. So determining the zeros would be to take this and set it equal to 0. And remember, we're just going to do our little t-chart. So we're going to take each of these factors and we're going to set them equal to 0. Okay, so for the first factor, I'm going to subtract 8 from both sides, and one of my zeros is negative 8. There's my first 0. Okay, let's take the middle. So I'm going to subtract 3 from both sides, which will give me 2x equals negative 3. And then I'm going to divide both sides by 2. So I have x equals negative 3/2. So there's my second 0. All right, and lastly, I'm going to take my last factor here, add 5 to both sides, divide both sides by 3, and then I end up with x equals 5/3. So these are your three answers. X equals negative 8, x equals negative 3/2, and x equals 5/3. Okay, so this question is asking you to determine the values of x that make the fraction undefined. Remember, undefined means that we're going to take this denominator, we ignore the numerator, and we set the denominator equal to 0. So 4x cubed minus x squared minus 3x, and we want to figure out what values of x could we plug in here and get x equals, and get the denominator equal to 0. So I'm going to look at this and I said, well, I think I'm going to factor this, and I notice that there's a GCF of x, so I'm going to take that out. So I factor out the x, and I have 4x squared minus x minus 3 equals 0. Okay, well, I see that my lead coefficient is a 4, So I can't just do regular AM factoring, so I'm going to do the rainbow. All right, so I have to figure out what multiplies to negative 12 and adds to negative 1. So remember, let me keep this x, bring that down, and I'm just going to open up a set of brackets. It'll make it a little bit easier. Remember when we're doing rainbow, you bring down the first term and you bring down the last term. Okay, so what multiplies to negative 12 that would add to negative 1? Well, wouldn't that be a negative 4 and a positive 3? And just a reminder, if you watched the video on number 5, the reason why there is an x here and here is because our middle term here has the variable x. So whatever variable is here in that middle term will be what you're going to have here next to the two numbers. Okay? All right. So next, remember, we group and group. We keep bringing down that x. And in my first group, I see that I have a GCF of 4x. So that will leave me with x minus 1. And my second group, I see that I have a GCF of 3. And that's also going to leave me with x minus 1. Bring down that x again. And here we go. So I'm going to take my GCFs, which was the 4x and the 3, put them together, and x minus 1. Put that. Okay, now let's stop. I like to reread the question. So it says determine the values of x. Determine the values of x basically means that you have to solve for x. So I'm not done down here. So I'm going to do my little t-chart. Well, my first factor is x. Oops. Equals 0. My second factor, I'm going to take that, set that equal to 0, and the same thing with my third one. All right, well, the second factor, we're going to subtract that 3 over. That'll give us 4x equals negative 3, and then we're just going to divide by 4. So x equals negative 3 over 4. All right, last one, we're going to add 1 to both sides. We have x equals 1. So it says determine the values of x that will make the following fraction undefined. That would be x equals 0, x equals negative 3/4, and x equals positive 1. So when we're solving for x, and we have a fractional equation, remember what we want to try to do is we want to try to get a common denominator first. So I'm going to start by factoring my denominator that has the trinomial in it. So the one on the far right here, I'm going to factor that using AM, and that's going to be x minus 4 and x plus 3. Make that look like a plus. Okay. So if you look at what we have now, we can see that I have a factor of x plus 3 here, and I also have a factor of x plus 3 here. So that's going to be part of our common denominator. Now the one thing that we do need to be careful of is see that I have an x minus 4 factor here, but this is 4 minus x. And remember, these guys are opposites of each other. So the easiest way to tackle that, if you recall, is just by taking this 4 minus x, I can make it x minus 4, but remember, I need to then multiply by a negative 1. And the easiest thing to do is to take that minus sign right here and turn that into a plus sign. Okay, because what we're doing is we're multiplying that second fraction by a negative 1. So changing that minus sign to a plus sign would be the easiest way to go about that. All right, now, the next thing that we want to do is to figure out the common denominator all the way across. So I see that my first fraction, this one right here, is missing a factor of x minus 4. So I'm going to multiply by x minus 4, a factor of x minus 4 in the denominator. And what I do to the bottom, I need to do to the top. Now, this is probably going to start looking a little bit ugly here. I'm going to have to write it here in front. I don't usually do that, but just for the sake of not having a lot of space. Oh my goodness gracious. Sorry about that. That's a 4. I'll rewrite it. So I would multiply that numerator by x minus 4. Okay, so then let's look at the second fraction. This is going to be just as ugly, by the way. So this has an x minus 4, so it's missing the factor of x plus 3. So that middle fraction there is going to get multiplied by a factor of x plus 3 in the denominator, as well as in the numerator here. So that's going to be x plus 3. That looks a little bit better anyway. Okay, so remember when we have fractional equations, once we get the common denominator and we've readjusted our numerators, we can just cross off all of our denominator stuff. Okay? All right, let me rewrite this so that this looks a little bit prettier. So I'm going to start by looking at my first fraction's numerator, which is right here. And let me just kind of rearrange that so that looks a little more organized. So we've got 2 times x minus 4. Okay, that's better. Now let's look at my second fraction. Remember we changed this minus sign to a plus sign. And I've got 3 times the x plus 3. All right, so plus 3 times x plus 3 equals, oopsie. Now, we didn't really do anything to this last fraction here except factor the denominator so we could help find a common denominator. So this denominator already had everything. It already had x minus 4 and x plus 3. So we didn't need to multiply the numerator by anything. So in that case, all we're going to do is just copy down the numerator. So 2x minus 2. Now that's so much easier. Now all we have to do is just distribute and solve. So I have 2x minus 8 plus 3x plus 9 equals 2x minus 2. Okay, let me combine like terms on the left side. So that's going to give me 5x plus 1 equals 2x minus 2. Now, I'm going to combine like terms, so I'm going to move that 2x over. And that's going to give me 3x plus 1 equals negative 2. I'm going to subtract 1 and subtract 1, which will give me 3x equals negative 3. Lastly, let's divide by what's in front of the x. And I have x equals negative 1. Now, you want to be very careful when you do this, that you want to check your answer and just make sure that the 0 that we got, the solution that we got, doesn't make the denominator of any of the fractions, the original fractions, equal to 0. So we don't want to have an undefined fraction. So I know it's tough to see because I just canceled everything out, but let's look right in here. If I put in a negative 1 here, do you see that I will not get a 0? So that's okay. That's all good. Now let's go right here to this second denominator. Same thing here. If I plug in a negative 1 here, I won't get 0, which means this fraction won't be undefined. Okay? And the same thing with the last one. Now, I could plug in the negative 1 here and do all the work, or really, if I just put in negative 1 here and here, you'll see that neither of these factors will end up being 0. So then I know that this answer here is not going to give us an extraneous root. Okay, so there we go. So much like number 7, number 8, we're going to take the same route. So I noticed that my first fraction, the denominator is a trinomial, so I'm going to factor that. And that's going to help me get a common denominator. So I have a minus 5, and I have a minus 2. So you can see that on the right side of my equal sign, I have an a minus 5, and I also have an a minus 2. So that's going to be my common denominator. So I know that this fraction here is missing a factor of a minus 2, and this fraction here is missing a factor of a minus 5. So I'm going to start by multiplying. Oh boy, this is going to get ugly, I'm sorry. I'm going to write it underneath, and I know that that's ugly, but a minus 2 in the denominator. That's supposed to be multiplied by the a minus 5. I'll draw a little arrow there. And then this also is going to get multiplied by a minus 2. I'll rewrite it. And then the last fraction is missing a factor of a minus 5. So the denominator and the numerator get multiplied by that factor. So now remember, once you have that common denominator, you can cross out your denominators, and now we can rewrite our numerators and solve. So I didn't need to multiply the first fraction by anything, so I'm just going to bring that 2 down. Now, my first fraction on the right-hand side of the equal sign, let me just rewrite it, got multiplied by a minus 2, and then there's a minus sign. And then my second fraction on the right side of the equal sign got multiplied by a minus 5. Okay, so let's distribute here. So I have 3a minus 6. Now be very careful here. I am not only distributing this a, but I'm distributing this negative sign as well. So be careful when you distribute that you distribute that negative sign. So that's going to give me negative a squared, and that will be a plus 5a. Okay? All right, so let's keep going. So I'm going to get 2 equals 8a minus 6 minus a squared. All right, well, that looks a little yucky. And I'd like to try to get everything to one side and set equal to 0 because I see that I have a quadratic here because my highest power is a 2. But I don't usually like the lead coefficient to be negative. So I'm going to take all of this stuff and I'm going to move it over to the left side. Okay? So that's going to make the a squared positive when I move it over to the left. And that's going to make the 8a negative when I move it over to the left. And lastly, if I move the 6 over to the left, that will make that a positive 6. And so do you see that that's going to give me a positive 8? And then I can set it equal to 0. Okay. Now, the directions say to solve for x, by the way, and we have an a, but, you know, we're just going to pretend that it says solve for a. So my next thing would be to try to factor this. So I'm looking for numbers that add to negative 8 that would also multiply to positive 8. And there isn't anything. Because 8 and 1 would multiply to 8, but that doesn't add to negative 8. And 4 and 2, same issue. So I guess I have to do quadratic formula. If something doesn't factor, remember then the next step is to try to do quadratic formula. So I'm going to write a equals, and remember the formula is negative b, so that would be actually, my b is negative 8, so negative b would be positive 8, right? Plus or minus the square root, and here we go, b squared, so negative 8 squared, which is 64, right? Minus 4 times a, which is 1, and c, which is 8. And that whole thing is over 2 times a, which is 1. Okay. Now, I can put this radical in my calculator, and when I do that, I'm going to get the square root of 32. And I know that the square root of 32 can break down to 16 times 2, and 16 is a perfect square, right? So I'm going to write a equals 8 plus or minus. All right, here we go. So the square root of 16 times 2. Well, the square root of 16 is 4, but the square root of 2 is just the square root of 2. And then we divide this by 2. Okay. So now you should hopefully see that we have common factors that we can divide by. So these three terms have a common factor of 2. So this 2 would become a 1, the 8 would become a 4, and the 4 would become a 2. So then my final answer is going to be A equals 4 plus or minus 2 radical 2. You can put it over 1, not necessary though. There are your answers. So you should take the time to just read through this question once or twice. All right, now we've done questions like this in your notes packet, and we're going to set up an equation, a fractional equation, and we have 3 people here, so we should have 3 fractions on one side of the equal sign. So because it says that Mark working alone can rake the leaves in 8 hours, so remember what we do is we take Mark's time and we put it under 1. And then it says Sean working alone can rake the leaves in 6 hours. So we take his time and put it under 1. If you read the question, though, it asks you to determine how long it's going to take Kara working alone, right? So we don't know how long it takes her. So that would be represented by X, and again, under 1. And remember, we always set this equal to the total. So in other words, if all 3 people work together, how long would it take them? Well, it says it takes them 3 hours. So then we make this 1/3. Okay, now we're looking for a common denominator of 8, 6, X, and 3. Well, the common denominator for 8, 6, and 3 would be 24, right? But we need an X with that. So if I want to have my common denominator be 24X, then I know my first fraction here needs to get multiplied by 3X. Obviously, same thing with the numerator. Okay, now my 6 needs to become 24X, so that means the denominator and the numerator need to get multiplied by 4X. My next fraction, 1/x, well, it already has the x. The only thing that's missing from that is the 24. And lastly, the 3, well, that needs to be 24x, so I need to multiply that by 8x in the numerator and the denominator. Okay, well, we've got a fractional equation, so we can cancel out the denominators. And now let's just rewrite those numerators. Well, all the numerators initially were 1, so 1 times anything is just itself, right? So we really then just have 3x plus 4x plus 24 is equal to 8x. All right, so that gives us 7x when we combine like terms, right? Plus 24 equals 8x. Let's subtract this 7x over, and we get 24 equals x. So, reading the question, it says determine how long it's going to take Kara to rake the leaves on her own. It's going to take Kara 24 hours. Don't forget your units of time, okay? The directions are asking you to look at the graph and just write true or false next to each statement. So let's look at the first one. So A says there's 1 relative maximum and 1 relative minimum. So let's look at the graph. So if we follow this graph up, there's our relative maximum, then it goes down, and here's our relative minimum. So there's 1 max and 1 min. So then that statement, A, would be, true. B, there are 2 intervals where the function is decreasing. Well, let's look here. We start here, we're increasing, so that's not it. But we are decreasing right in here, so there's 1 interval where we're decreasing. And then right here, we're increasing again. So there's only 1 interval of time where the function is actually decreasing. B says there are 2 intervals where the function is decreasing, so that would be false. C, the degree of the polynomial is odd. Up, down, up. That's 3 direction changes. Increasing, decreasing, increasing. So 3 direction changes means that the degree of the polynomial is odd. All right, there's a positive, negative coefficient. I think that means, sorry about that, this should be a positive leading coefficient. Okay, I can't fit it in there to write it, but it should be on your paper a positive leading coefficient. All right, so let's look at the lead coefficient. Remember, if the polynomial is an odd degree, then we start from the left right here and ask ourselves, what are we doing first as we start walking? And if you look, we start walking and we're walking up. So that is a positive leading coefficient. So the answer to D is true. Okay, let's look at E. When f of x is divided by x minus 3, the remainder is 0. Well, if x minus 3 is the factor, remember that the 0 then would have to be x equals positive 3. So let's look at the graph. So if x equals positive 3 is supposed to be the 0, well, this isn't working, is it? Because if this is supposed to be the 0, shouldn't the graph cross the x-axis right here? And it doesn't. It crosses it at 2. It crosses it at -1. It crosses it at -3, but not a positive 3. So E would be false. All right, let's look at F. When f of x is divided by x, the remainder is -6. So if f of x is divided by x, that means x would be a factor, but the 0 would be x equals 0. Okay, so I'm going to say that again. If f of x is divided by x, just like f of x being divided by x minus 3, this is a factor, so is this. So to find the 0 here in part E, we just changed the sign and made it positive 3. Remember, when this stands alone, that's equivalent to x equals 0. So let's find x equals 0. Here's x equals 0 on the graph. Now, if we want to find the remainder, we go down, in this case, to where x equals 0 is on the graph. And right there it is. Okay, and look at the y value that it corresponds with. That's at -6. So this is true. The remainder is -6. So that would be a true statement. Okay, G is talking about end behavior. So as we go to the left, right, as x goes to -infinity, that's working to the left, our y value is going down. All right, so let's look at the picture. As we're going to the left, is our y value going down? Yes, it is. All right, let's double check this one though. As x is going to infinity, aka as x is going to the right, y is going up. That's what that says. So as x is going to the right, y is going up. And let's look at that. As we go to the right, look at what happens. Yes, our y value is going up. So then G would be a true statement. All right, last one. H, a possible factorization of of f of x is x minus 3, x minus 1, and x plus 2. Well, let's look at the zeros here. So if I look right here, I have a 0 at x equals -3. Well, that's its 0, so remember, its factor would be x plus 3, wouldn't it? Well, right away, I know I have a false answer here. But let's keep going. So I look at my next 0. That's at x equals -1, which means that factor should be x plus 1, which again is not what I have. But let's keep going anyway. Here we go. My 0 is at x equals 2, which means my factor should be x minus 2, which is not what I have in H. So H then would be false. If I factor a, I can look at that and I say that that's a binomial. I'll always look for a GCF, but there is not a GCF in part A. So then I'll say, oh, well, wait a minute, that's dots. So I know that the square root of 121 is 11. Dots, we always have a plus and a minus. The square root of 9 is 3. And then the square root of c to the 6th, remember when it's an exponent, all we have to do is take half of that exponent. So half of 6 is 3, and this would also be 3. So there's part A. All right, now let's look at part B. Part B is a trinomial. So again, though, please remember that any time you're doing any kind of factoring, you want to see if there's a GCF. Okay, but there isn't one. So if there isn't a GCF, I also notice that my leading coefficient is not a 1, it's a 3. So I'm going to have to do rainbow here. So if I look at my rainbow here, I'm going to have what multiplies to negative 36 and adds to 16. So with rainbow, we bring down the first term, we bring down the last term, and then we ask ourselves what multiplies to negative 36 and adds to a positive 16. Well, that would be a positive 18x and a minus 2x. I'm going to group, and I'm going to group. All right, so I'm going to take out a GCF, and that's going to give me 3x and an x plus 6. And then I'm going to take out another GCF. This one's going to be minus 2, and that's going to be x plus 6. So final answer, 3x minus 2 times x plus 6. And I probably should just go back up here and box that off as well, right? Okay. All right, so part C. Well, part C, in some ways, I kind of think that's easier, because if I look at that, I notice that I have 4 terms. So I know that I'm going to have to factor using grouping because I have 4 terms. Now, I still always would like to see if I have a GCF here. So let's just see. I have a 3 that I could take out of all 4 terms, don't I? So let me take that out. So if I take a 3 out, factor that out, that's going to leave me with x cubed minus 4x squared, right? Plus 5x minus 20. There we go. Now I'm going to group, and I'm going to group, and let's keep going. I'm just going to use brackets here because sometimes it's a little less confusing. So my first 2, I can take out an x squared, and I see then that I'm left with x minus 4. And then my second group of 2, I can take out a 5, and I can see I'm left with x minus 4. So then I'm going to have 3 times x squared plus 5 and x minus 4. And there you go. So I would start by distributing the 6 through to the right side of the equal sign. So that's going to give me 9x squared equals 6x plus 12. Now, I am solving for x, and it is a quadratic because my highest power is a 2. So I'm going to move everything to one side and set it equal to 0. So I'm going to take all of these terms here and move them over to the left-hand side. So remember, when I do that, though, I have to change the signs. So I'm going to have 9x squared. That's going to stay. But when I move that 6x over, it's going to become minus 6x. And my plus 12 is going to become minus 12. Equals 0. Okay. Well, I'm going to look and see, well, I do have a GCF of 3, right? So couldn't I just divide everything by a 3? Which would give me 3x squared minus 2x minus 4, right? Equals 0? Okay. Now, I would try to factor this, and I would definitely have to do rainbow, right? Because I have a lead coefficient that's a 3. So what multiplies to negative 12? Oops, that's supposed to be a negative 12. And adds to a negative 2. Well, the only thing that multiplies to 12 is 4 and 3, 6 and 2, and 12 and 1. But none of those, if you add them or subtract them, is going to give me a negative 2, which means then that this doesn't factor, which means then, if it's a quadratic, we are going to be doing the quadratic formula. All right, so here we go. So x equals negative b, which would be a positive 2, right? Because b is already negative 2, plus or minus square root b squared. So negative 2, if I square that, is 4, minus 4 times a, which is 3, and times c, which is negative 4. And the whole thing is going to be over 2 times a, which is 3. Okay. Then if I take this square root and I put that into my calculator, that's going to give me the square root of 52. And I know that that breaks down to 4 times 13. All right, so let's keep going here. So I have x equals 2 plus or minus. Now, I've got the square root of 4 times 13. Well, I know the square root of 4 is 2, but the square root of 13 doesn't break down. I put that over 6. Right, so I see that 2, 2, and 6, all three of those, have a common factor of 2. So I'm going to divide this by 2 and get a 1, divide this by 2 and get a 1, and divide this by 2 and get a 3. So, final answer, x equals 1 plus or minus. Now you can write 1 radical 13, or you can just write the square root of 13, all over 3. And there's your solution. So in the last question, it asks you to algebraically prove. Remember, when it asks you to prove, that means that when you're looking at this equation here, you have to manipulate one side of the equation, but not the other. So in other words, one side of the equation has to stay exactly the same the whole time. So since there's less going on here, that's the one that I'm going to leave alone. And then this is the side that I'm going to manipulate. So this is what I mean by that. So now I know that this is dots. And just so that you kind of understand where I'm coming from, you don't have to write this. But off to the side somewhere, it's probably not a bad idea. X squared minus 1 is x minus 1 times x plus 1. Now the reason why I'm writing that is, look at your denominators to the left of the equal sign. Do you see I have the x plus 1? However, the x minus 1 that I have here is the opposite over here. So remember what we can do when things are the opposite. So I can make this into x minus 1, remember, which is the opposite, which will match what I have right here, except that, remember, in order to do that, I'm going to change this sign to its opposite sign, which in this case would be a minus sign. Okay? All right, now let's get the common denominator. So my first fraction over here on the left-hand side would have to get multiplied by x minus 1 so that it matches the denominator I have over here, right? Okay, but obviously if I multiply the denominator by x minus 1, the numerator needs to get multiplied by x minus 1 as well. Let's go to the middle fraction then. It already has an x minus 1 in the denominator, so it needs an x plus 1, numerator and denominator. And, well, my last fraction is totally fine. So let's just kind of rewrite then what I have going on here. So on my far left fraction, I have, let me just point it out, I've got 1 times x minus 1, right? So that's just x minus 1 over x plus 1 times x minus 1, right? Okay, now don't forget that this plus turned into a minus, so we have a minus. And we have 1 times x plus 1. Well, remember, 1 times anything is just itself. So I'm going to have minus x plus 1. Now, I like to, whenever I am writing a minus followed by more than one term, I like to write it in parentheses, and I'll go over why in just a second. Okay, let's write this common denominator then. So I've got x minus 1 and x plus 1 equals. Now remember, when we're proving, we have to leave one side of this equal sign exactly the same, so we can't touch anything. So I'm going to write this denominator as x squared minus 1. But remember, I am smart, and I know that x squared minus 1 really is x minus 1, x plus 1. So in my next step, I'm going to change all of these guys to just x squared minus 1. All right, so I've got x minus 1 over x squared minus 1 minus, let me keep this in parentheses, I'll tell you why in a minute, and then I've got x squared minus 1 negative 2 over x squared minus 1. All right, so now let's solve the mystery of this little minus sign here and why I have parentheses, because remember, if I have a minus sign followed by more than one term, which I have 2 here, that minus sign needs to get distributed through to the x, and it needs to get distributed through to the 1. And so that's why I put parentheses there, because then that way you don't forget to do that. So this minus, or this negative, is going to get distributed through to both terms there. Okay? All right, so what I'm going to end up doing is I'm also going to consolidate that left side. Let me put it underneath one fraction. So x squared minus 1 is the denominator. Now, let's look over here. So over here I have x minus 1. So let me write that down, x minus 1. And then over here I'm going to distribute this negative through. You see that's going to give me a negative x. And then I'm going to get a minus 1. Let me say that again. So this negative, or this minus, times x will give me minus x, and then minus 1. Okay. So minus x minus 1. And then I'm going to keep the other side as it originally was, because when we're doing an algebraic proof, you don't manipulate one side of the equal sign. All right. Now look at what we have here. Well, isn't x minus x 0? So my x's are going to cancel out, but look at what I have here. I have a negative 1 and another negative 1. And miraculously, that is negative 2 over x squared minus 1, which, voila, is the same as the right side. We are mathematical geniuses.